We'll be investigating the idea of factoring even more by looking at trinomials, polynomials with three terms, that have a leading coefficient of 1. We can recall our idea of foiling, or really multiplying two binomials, and specifically we're going to be looking at linear binomials, such as x minus 2 and x minus 5. Multiplying these binomials, we get the trinomial x squared minus 3x minus 10. So now we're going to take this trinomial and work backwards to find the two binomials. This is what we're calling factoring. We can recognize that the binomials, specifically the linear binomials we work with, follow a similar form where we have x plus some number times x plus some number. And this would be in the case where we would have x squared plus bx, and we would be adding a c term. Okay, things would be multiplying to a positive term. If we had x plus some number times x minus some number, we would have x squared. Depending on where we're at, we'd have plus or minus bx, but we would actually then be subtracting c, because those two numbers, a positive times a negative, would give us a negative number. And in the last case, we would have x squared minus a middle term plus c, because a negative times a negative is a positive, but would add to a negative. This will make more sense as we continue into factoring. So what does a trinomial with leading coefficient of 1 look like? Well, our example here, x squared plus 5x minus 6, has a leading term of x squared, and in front of that is a 1. We simply don't write that. Our non-example shows a leading coefficient of 3x squared. And what is the constant? We'll be looking at that constant. Remember, the constant is the number not attached to any variables, in this case, -6 for both of them. So we will be factoring trinomials with leading coefficient of 1 by looking for the pattern of products, meaning multiplication, and sums, meaning addition. So x squared plus 7x plus 12. We know that we are going to look at this constant first. And with this constant, we want to list all the pairs of numbers that multiply to that constant of 12, which are 1 and 12, 2 and 6, 3 and 4. Then we're going to choose the pair that adds up to our middle term, 7x. And we can see that 3 times 4 multiplies to 12 and adds to 7x. So we will now rewrite that trinomial as the binomial x plus 3, x plus 4. Foiling or distributing this, I have x squared plus 4x plus 3x plus 12. Notice in my foiling, my first two terms, x times x, x squared. That's why often these binomials follow that same pattern. And then I looked and added the plus 3 and the plus 4 by 4x, 3x. That would equal our middle term of 7x. And lastly, I'm left with that constant that I multiplied to of 12. So now if we factored x squared plus 2x minus 24, note that our constant is negative in this instance. So we need to list the pairs of numbers that multiply to equal a negative 24. And then we'll be looking for which pair adds up to a positive 2. Well, the pair that's going to add up to a positive 2 would be a negative 4 and a positive 6. 4 and a negative 6 add up to a negative 2, but we're going to be looking to add up to that positive 2 as our middle term in that polynomial. So now we need to write this as a pair of binomial factors. And that pair of binomial factors then is x minus 4, x plus 6. Notice how I kept the symbol of negative 4. The sign of that brought it back down into that binomial. Again, foiling or distributing this to check our answer. We see x times x is x squared. That is our first term. We then have a plus 6x minus 4x, which will combine to positive 2x and a minus 24. So we do end up with the same trinomial we started with, x squared plus 2x minus 24.